Hello friends, in this video presentation I'm going to deal with Matplotlib, or you can say for the visual representation of data in machine learning. So over here I have added following packages. For my ND array I will make use of Numpy. For my data frame I will be using pandas, and for matplotlib.pyplot will be responsible for the visualization. This whole thing will be abbreviated in the form of NP, PD and PLT. These are some standard abbreviation you can state. The following line is responsible for displaying the matplotlib bars or the graph within the Jupyter notebook or embedded within the Jupyter notebook. I need a chunk of data, and for that reason I'm using Numpy line space function that takes three parameters. The first parameter is the starting value, the second one is the ending value, and in between how many values do you want. So it will generate a finite difference between one value with that of the other one, and the whole Numpy array in the array will be stored within the variable x, or in the list within the variable list x. So if you want to display the type, you can see it's a ND array, and if you want that I will be seeing which values it has generated, which we can see over here. Here the value, the list of data you can see. So it's starting from 0 because it was 0 for the starting value. It will end at 10, and these are the intermediate values, and there is a difference which are very equal among each others. So all total there are 100 values that has been generated. Well, you might be wondering, why do I need this? Because I have to plot my graph, so I need both the values for x and y. So this will be working for my x. Now I need a y value as well. So how do I generate my y value? And for that reason I will be using Numpy Sine function. In the Sine function I will be passing this x, and it has a list of 100 values. So generally 100 values will be resulting in a list of y, which will be also 100 as far as Sine value respective to the y is concerned. So if you're going to print even the y list, you will find that it has generated subsequent values in the form of Sine. Okay, so basically I will be using this and this as my x coordinate and y coordinate, and that's how the thing will be plotted. So with this I can generate my graph, but what I wanted is that I want to generate one more graph, and for that reason I have used the cos or cosine value as well, and it will be taking my x value from the list, and it will be generating a resultant value that I'll be storing in z, and I will be seeing another list of cosine value right over here. Now if you notice one thing very minutely, a positive value as well as negative value will be generated, and this will help us to get the graph in a very proper shape. Okay, so let's move to the representation of the graph, and for that reason these following lines will be very helpful. So your matplotlib.pyplot will be making use of this abbreviation PLT, and it has a function called figure which will generate the workspace where the graph will be actually plotted. And to plot the graph you need the axis. So what should be the x position of the graph, and what should be the starting position, and how much should be its width, how much should be its height, and that's how this whole parameter will be determined, and we are going to get an instance in the form of an ax. So if we fire this following line, you will see that over here we have a graph, and starting from 0, 0, so this is the origin, and it has the width of 1.0 because of 1, and if you want to increase the width you can do even that also. Suppose I want to make it 4, so in that case you will find that it has extended up to 4. It's very tiny, you won't be able to see it very minutely, and it has the height has been up to 1 because I have value of 1. So if you want to increase this as well, I'm making 3. So if you fire that, and you will find that it has extended up to 3. Well, that's how the graph workspace got generated. So for standardized purpose I'm making it 1, 1 so that you can view it very properly, and here it is. Okay, so the workspace is pretty prominent. So this is the basic requirement to generate the workspace where the graph will be plotted, and now it's the time to plot my graph. Okay, what I will be doing is that I'm commenting these lines because I have already written the line right over here. So in order to plot the graph, and we have already seen the workspace, so how would I be using the plot function? And for that reason there are a few parameters which are going to make use of, As I already said that in order to plot a graph, we will be requiring two coordinates, x and y. So x will be the list and the y is the sine value. And I'm representing the color of my x graph in the form of red. So the color of the line is red, or the axis is the red in color. And I'm denoting it with a marker. Okay, over here I've given a symbol for the marker representation. These are the points where the values will be plotted, and this is a LW stand for the line width. So in order to make the line thicker, I've used 0.5, but if you want to increase the width, you can also go for that. Suppose I'm making it 5.5. In that case, the line will be pretty thick enough, okay, as you can see, but I would prefer 0.5. So that's how the line is all about. And the label is what I've, so the x axis will be represented by sine. Okay, in the same way I have also plotted my other graph, that is the cosine graph, with the help of the x z. So x coordinate, z coordinate, z as a list. I'm using it to generate the x-axis and y-axis, and over here I'm representing the line in the form of a green, and this is a marker, and I'm labeled with cosine. Okay, now if you see minutely, the axis has a limitation, has a height. So my x is ranging from 0 to 10, okay, and my y is ranging from -1. So here if you see -1 to 1, okay, because the value was in the range of 0 to 10. So that's how the thing is working. So assume that if you increase the height and the width, what will happen? So suppose if I want to increase this x-axis, so what I will do is that I will provide, instead of writing 0, I'm making it suppose 5. So what will happen as an outcome? The outcome you can see over here, that this is how the thing is getting generated, because I'm starting with 5. Okay, but what if I go for a negative? Suppose I'm going for -5. Okay, in that case, a very strange thing you will notice. It has been generated from -5, but actually the value is calculated from the 0 position, because my the line space has started from 0. So definitely 0 was the first value through which it's calculated. So even if I increase the x-axis, but it would actually start from 0. So this increment is of no use at all. And the same thing is meant for the height also. So if I increase the height beyond 1, okay, that would be of no effect, because it started from 1. See, if you go for the cosine, see, let me show you the cosine. It started from the 1, so that means it will be ranging up to 1. So let me just change even the value of, so -1 to 1. So I'm changing the value from 1 to suppose 5, and subsequently just see the output. See, this height is of no use at all, because it's actually the maximum value went up to 1. So that means this increment would be of no use. So let me make it back to the actual value which initially was started with, and in that case you will find that this is what the thing would be ranging from. So initially it was 0, 10. So you can find it's from 0, it's up to 10, and the same way from -1 it ranges from -1, and the height is up to 1. So that's how the graph got plotted out. And as a label, I have made use of x label over here as time, and I have made use of y label as amplitude. This is just a way of representation, I think, nothing big deal about it. And I've given a title over here, and that's the title which you can see right over here, So that's how the basic graph got plotted out. Okay, I'm just trying to show you that what is the fundamental way by which a matplotlib can be executed. But the interesting thing that we can see is that we have got two graphs over here that has been embedded on one single workspace. What if you want to seclude them so that it will be shown in a two different workspace? And that brings us to something called subplot. Okay, in case of subplot, we will be using the same data range, but now we are going to plot the graph in a two separate workspace, and for that reason we will be using plt.subplot. It has a concept of a number of rows and number of columns. Let's consider that this is one single row, so it has got the row as 1, and just imagine that it has got two columns. So this is one column, this is complete one column, this is another column. So that means 1, 1 would be represented this graph, and 1, 2 would be represented by this graph. Okay, that's how the thing has been determined. Okay, and over here there is a figure size that will increment the the width and the height of the figure. So what if I just omit this particular parameter? In that case, you will find that this is the standard way of representation. But if you want to increment it, in that case you can go for figure size. I'm making it suppose of 4,4 so that it looks substantially big enough. No, it's not at all looking good. So I will be making it 7,7, or otherwise I will stick to the initial value what it was. Yeah, now it is pretty good looking. So once you go for subplot, you will be getting two return value. The first one is a figure, and you will be getting a variable in the, but I have named it x. Okay, what is the purpose of this? This is what representing the individual column. So if I go for ax0, so that will represent me this particular figure, and if I go for ax1, that will represent me this particular figure. So in this particular figure, I have a function called plot, which we already used above. I will be using what are the standard thing which we saw at the top. The same thing can also be made use of, because if you can see over here, I have the plot function, the same plot function I'm using it. So xy I'm using, that means the line space x which I just originated over here. I'm using that, and then y was represented by sine and z was represented by cosine. The same thing I'm using over here also. So x comma y I will be using for this, that is the sine list comes in, and x comma z, that is the cosine, comes right over here, and the line color I have given as red and green. So that's how you can generate two different graph. Okay, and so I can assure that if you work on this particular principle, then you will come across a very basic and very fundamental way of generating a matplot. I work on Matplotlib for generation and visualization of graph, and I think that this video will help you to work on this, and I will try to make further videos in this regard. And please work on this, and thank you so much. Just wait for my next video. Until then, have a nice time.